Hey everyone, this is Wakas with Mobile Centrics, and I'm here to introduce to you XO7. That's right, XO7 is now available for the iPhones and the iPads. XO7 has been one of the most fun projects for us. We've been focusing to get away from the TFT panels and moving into the in-cell realm. Now, when we look into the in-cell industry, we've seen that, hey, currently the models that we've carried and the market has been carrying has just been a lower grade in-cell panel. Now, once we transition from XO4, 5, and 6, we've learned a great deal of how technology during the assembly process and everything works. But in Excel, it was a brand new start for us, and we had to go right back to the drawing boards. When we stepped into the in-cell realm, we learned that there's two types of panels out there. One is the alpha glass, and second is the LTPS model. All of China currently primarily just uses a alpha glass. The difference between LTPS and alpha glass is that alpha glass would use a bigger diode on the LCD panel, and it covers up more space. And being bigger, it would actually cause higher temperature, longer latency, and it would cause a lag in the screen as it's transitioning colors. With LTPS, it keeps it at a lower temperature, the battery health is saved, the color are much stronger and better due to the fact that the filters or the diodes are much smaller. Now, LTPS hasn't really been played too much, one because of the costing factor, and second because it's a completely new that the China market hasn't really looked into. We've pushed the manufacturers to develop a LTPS panel for us, and we've used our previous experiences and knowledge on flex cables, on the backlights, to develop the best LTPS panel available in the market. So for the XO7 in-cell technology, one thing that we focused is that, hey, we should theoretically, our always mission has been to match the colors of the OEM models. But with XO7, we kind of stepped back and took a look at it and saw that, hey, we don't need to actually match the colors of the OEM panel. We should just be seeing, hey, how the industry has changed, and the color accuracy, the gamma lights have all changed between the models of iPhone 6 all the way up to the newest iPhone 11. So our main focus has been, hey, let's take the colors of the iPhone 11 and try to bring it all the way down to iPhone 6. We don't have to match the iPhone 6 with its own replacement part. So all these panels have been engineered to kind of match closer to the newest color accuracy by the manufacturer. One of the same technologies for the backlight that we used on the XO6, we're transitioning that into the XO7. The other thing that we've looked into for XO7 is that, hey, when the LCD panel sits on the frame, causing pressure at this point can easily damage the LCD panel. So rather than just having the backlight sit on the frame, we've also sealed underneath it a silicone layer. So what that would do is any gap due to the polarizer OCA, it's all the way extended all the way to the bottom of the LCD, which is going to heavily improve any type of malfunctions or anything along those lines. So what's the big advantage of LTPS in-cell to a TFT panel? The old panels were working fine. There is a huge difference. One of the major differences is that on a TFT panel, the digitizer is actually separate from the LCD. What that means is that you're going to, even when the device is powered off, you're going to be able to see grid lines on it. Not what we're looking for. The second thing you'll see is that, hey, when in digitizer panel separate from the LCD, there's two layers of OCA and there's a digitizer layer itself, causing a little bit more thickness. So no matter how thin you can make the IC chip, it's still automatically going to be thicker compared to an OEM. So with LTPS in-cell technology, we're getting rid of that. We're going to make it as thin as possible. So now even if the IC chip is a little bit inflated on it, it still won't make a difference because there's so many less layers when constructing this panel. So what can you expect when you get the XO7? Every XO7 panel will come with the camera ring, proximity bracket, earpiece mesh. Each LCD would also come with a steel plate pre-installed, and it comes with a water seal adhesive within its package. XO7 panels will be marked with a XO7 engraving right on the flex, just so it can easily identify the model and brand. And now, let's talk about the XO7 for the iPad. We're super excited about the iPad. We've been working really hard on this and we're very grateful for all the feedback from all of our customers. We're going to start off going with the digitizer models and then the LCD panels. For the iPad digitizer models, we'll be carrying iPad Mini 1 and 2, Mini 3, Air 1 and Air 5, iPad 6, and iPad 7. All 5 models will be readily available for XO7. For the LCD assemblies, we'll be carrying iPad Mini 4, Mini 5, Air 2, Air 3, 9.7, and 10.5. One of the things we really wanted to improve on was the packaging for the assemblies and the digitizers. We wanted to make it convenient where a store owner could actually leave it vertically on his shelf and still be able to see the models that he physically has. We wanted to be able to change the colors, and we wanted to make the LCD assemblies come in packaging that's going to be much more protected. They're a little bit thicker panels with EVA foams all on the inside. EVAs on the front of the panel and at the bottom. So ensuring that the assemblies stay secure. So what's made XO7 so unique? There's 5 key factors. Number 1, we took the cover glass and we made it thinner. We made it to a 0.5 thickness. One of the key reasons for doing this is to be able to ensure that the home button can stay flush when installing it to the cover glass. Now the market primarily only carries a 0.6 or 0.55 thickness. Number 2, XO7 digitizers, they're strengthened using Casper technology. That has allowed us to reach the 0.5 thickness. It ensures that the cover glass will stay strong even during bends and breaks, and it's much stronger comparative to a 0.6 and 0.5. To prove that, you can do a bend test. So for the iPad digitizers, you should be able to bend them in any angular motion. Also, one thing that we've seen that techs have been having trouble to is after the installation, normally when they're lifting the digitizer back up, they easily crack it. With this, you should be able to bend the digitizer all the way back up to its full strength. So, due to the feedback from all our customers, we've learned that, hey, when testing the digitizer outside the device itself, the digitizer will work perfectly. When they're installing the digitizer and folding the cable over, what would happen is that the digitizer will be ghost touching or there will be lines. So we did more research into it and found out a solution for it. One thing we're doing underneath it is we're going to glue down the flex cable to the cover glass. So when during tugs and tears, it won't separate from the positioning of the digitizer. And next, we looked into the soldering technology used to fuse the digitizer with the flex cable. We did more research into it and used a much higher technology to fuse the flex cable to the digitizer, the painting of the cover glass. Now, traditionally, when the black color is being painted, it's a very simple color to match. But white's a much harder color to match with an OEM. So traditionally, the market will just do 4 layers of paint. Three layers of white, followed with a gray coat on the back of it. What the gray coat does is it ensures that there's no reflection when the LCD is turned on or the reflection coming from the backlight. But we knew that the colors weren't as nice. We knew the colors weren't matching even the home button or compared to an OEM. We decided to bump it up. We bumped it up to 7 layers of painting to ensure the proper color and to ensure that the white is bright and enriched. The part that we're most excited about, the main core. So on the digitizer, I'd like to explain first how does it actually work, and we can kind of go into what we've seen into it and what we're going to be doing different. So typically on a digitizer panel, there's going to be a layer of vertical lines followed by a layer of horizontal lines. So how is a TP really built? Well, simple. What the OEM manufacturers is able to do is they're able to take a clear TPU film and spray it with a mixture of copper, nickel, and titanium. They mix those compounds together and spray it on one side of the TPU, flip the TPU over and do it the exact same thing on the other side. What they would do is they would next take it to a laser machine where they can etch out the necessity grid lines running vertical on one side and on the back side horizontal on the other. Afterwards, they'll take it to an acid wash where they'll get to rub off all the excess coating that was applied to the TPU layer. So what have we done in XO7? Well, to use one TPU layer and using dual-sided grid lines, it's due to difficulty in manufacturing, that's a little bit harder process. What we've done is we've taken two TPU layers and used the same mixture, copper, nickel, titanium, and been able to spray both sides on it and fuse them together to achieve the same vertical and horizontal grid pattern. Using this mixture has allowed us to reduce the visibility of the grid lines. Also, this conductivity will allow for more of a flawless experience for the end user. XO7 LCD. 3 major improvements. The custom backlight. Now, iPad aftermarket LCDs, they've primarily just been a few suppliers that manufacture the backlight. The quality, super poor. The performance sucks. We knew that definitely that was one of the first main things that we needed to target. Everything we learned from XO4, 5, and 6 for developing the backlight, we brought the same technology over to the iPad realm. So a custom-built backlight with adjusting the gamma lights, adjusting the hues, opening up an ESR film in the back, has all been developed into this particular backlight. So what does this do? Better colors. I mean amazing colors. I mean, once you see it, definitely a winner. Number 2, a more robust seal between the LCD panel and the digitizer. So one of the key feedbacks that we've learned from our customer are that, hey, when they're getting the iPads, is that they might get a solid line running down the center, or they might get a blackout, or they'll have a bleeding in the corner. That can only be caused by 2 things. Either A, shipping, that hey, during the shipping process that it could have gotten in the impact near where the LCD board is. Or number 2 is that when the tech was trying to do an installation, he applied too much pressure right over here. So we knew that had to get resolved right away. And number 3, the small D-lig tails. Honestly, those really count. For instance, the home button bracket. Now I know that, hey, it's such a minuscule thing to add 2 lines on the side and to allow the tech to be able to position the home button bracket. But honestly, it actually really helps. One thing we've seen is that, hey, with the aftermarket LCDs, you might find 100 stamps all over the backlight, and every time they're applying pressure on this, guess what? There's a high chance that there's going to be a white mark on the front side when there's going to be a pressure mark on the front side when the shop owner installs this LCD panel. So we've actually even layered it with a fingerproof, dustproof film on the back. As I said in the beginning, XO7 has been a really fun project for us. Honestly, I think we learned a lot on the way. We learned a lot about the production of digitizers. We learned everything about the iPad LCDs, what the little nuances, the problems, and everything like that. We went into fine detail of simple things of making sure that Tessa tape comes pre-installed on all our iPads, the digitizers or the LCDs. So we're making sure that, hey, that this experience that the tech's going to have when doing this installation should be near perfect. And we're excited to share this with you now. I'd like to go into a little bit of a comparison on what XO7 is compared to what the market has. So this is some of our competitors' parts, and we can kind of go into it again. We'll keep XO7 here and see. So what do we have that's different? You'll see that, hey, after removing this knocker cushion, you'll see that, hey, that the original digitizer is a mixture of copper. It looks quite closer to an OEM, and comparative to, well, let's just take a copy digitizer. Now this is as bad as it gets. I mean, it's primarily just the cheapest possible digitizer available coming out of China. It is made out of plastic as well, but the sensitivity on this is super weak. I mean, we've played with these, the grid lines are very heavy. There's no form of copper or anything like that. The digitizer is built with the lines directly running onto it, not a copper layer or anything like that. It's purely plastic. Next, we move on to another supplier's Copy Select digitizer. Now this digitizer is a little bit better. It has a silver lining on it, using silver as the form of conductivity. This one still uses a two-layer technology where it's fused together. However, it uses silver rather than any type of nickel, copper, or titanium. When you're going to be looking into digitizer lines, they're going to be heavy. So, not so great. And what does the market consider a premium digitizer? The good thing I am seeing is on all of these is that, hey, everyone has decided to put Tessa tape on all of them. And this one looks to be, hey, this looks pretty good, right? Let's take this into consideration. I'm saying that, hey, look, it has goldenish, copperish film on it, so it must be a very good digitizer as well comparative to the rest. Well, it doesn't look like it's real. I think it's a film. Let's test it out. Huh. What do you see? It looks to be called premium, but it seems like it's just another plastic digitizer. Quite similar to the other one, we'd say. Actually, it's identical. Yeah, pretty much identical. The only difference was that the difference between premium and the copy is a piece of tape. Interesting. I don't believe it. Let's see if Mobile Centrics is also peelable. Seems like there's no layer difference. I think we're gonna have to cut through the digitizer to even get to this. It looks to be all built in to the digitizer, and that is the grid line itself. Oh look, what do we have here? The digitizer itself, not a secondary tape. First layer, second layer, with all the conductivity lines and everything like that. So as we can see that there's many names for aftermarket. Now how we present it is, how the market presents with different names is something that we're very big on changing in our platform. We've come out with badges to clearly specify that, hey, this is an aftermarket, that this is not anything OEM or premium or copy. So aftermarket shall be named aftermarket, and so on. Now moving on to this one. Well, it's not so bad, it's silver. What does that mean? Well, most likely it means this is not a film. This is most likely a piece of glass. So bend test, this wouldn't last. This honestly wouldn't even last an inch. As soon as I can feel the resistance that, hey, this is going to easily crack. Why? Because, let's take off. This is a piece of glass. So what does that mean? Well, during impact, glass is easy to crack. If I put some pressure here, boom, broken. As you can see, quality is different quite differently. Let's try a bend test. So taking the same glass, moving it. Ooh, that didn't even take long. Let's try that with XO7. How much resistance will it take? I think for 2 hands I can't even crack it. That's how it should crack. move on to the next one. Nope, that's a week. Couldn't take much of a pressure pass here. Try it again on the last one. Try it on the premium, or so-called premium. Sorry, premium. XO7, you gotta try it. XO7 is for you. You cannot do this without you. Thank you for all your continued support. Mobile Centrics is on YouTube, Facebook, and Instagram.